In this video, we'll walk through the electrical design for a microinverter PV-only system in Solargraf, with the goal of generating a single line diagram. At this point in the project, the solar modules and microinverters have already been placed in the Solar Design tab. And since this is a PV-only system, there is no battery included in the design. So from here, we move into the electrical section, where we'll configure the system components needed to generate the single line diagram. The first step is branching the microinverters. In this section, you'll see two options: manual stringing and auto stringing. In most cases, auto stringing is the preferred method because it quickly creates balanced branches based on the inverter configuration. Once that's complete, open the line diagram section and verify the string configuration. Here you can confirm how the system has been organized and continue configuring the rest of the electrical design. Because this is a microinverter system, so we move directly into the AC system configuration. This section defines the components that connect the system together and ultimately build the single line diagram. The first component you may choose to add is a junction box. This is optional and typically depends on the installer's preference or the layout of the roof. If a junction box is used, you can place it directly on the roof. And once it's placed, the inverter branches will automatically connect to it. Next, we add the combiner box. For N-phase microinverter systems, the combiner box is a required component. This is typically installed on a wall, often near the main service panel. You'll also see an option to add an external PV disconnect. If enabled, from there, you can configure whether it is fused or unfused, and whether it uses a 2-pole or 3-pole configuration. Because this design is PV only, a sub-panel is typically not required. Next, we place the main service panel, or MSP. Here you can enter additional information, such as the utility meter number, although these fields are optional. Currently, Solargraf generates single-line diagrams for 240-volt single-phase residential systems. Next, select the tie-in method, which defines how the solar system connects to the main panel. Options include load-side breaker connections, line-side connections, and split-bus configurations. In most residential installations, the load-side breaker connection is used, so that is typically the selection. After that, enter the main breaker rating and the bus rating for the panel. The default configuration is often 200 amps for both values, but these can be adjusted if the installation uses a different panel. If the project requires a main panel upgrade, you can enable that option and enter the upgraded specifications. We'll assume the system is connecting to an existing panel, so the default values remain the same. Return to the line diagram section and select Generate Line Diagram. Solargraf will compile the electrical configuration and typically generate the diagram in about 20 to 30 seconds. Once the diagram is ready, it appears on the right side of the screen. You can expand the view and review the complete electrical pathway from the microinverter branches through the junction box if used, into the combiner box, through the disconnect and optional production meter, and finally into the main service panel. The diagram also includes key details, such as breaker ratings, combiner box model information, gateway integration, and system connection points. If everything looks correct, you can download the single line diagram. Solargraf allows you to export the file in PNG format or DWG format, which can be used for engineering documentation or permit plan sets. And that's how you complete the electrical design and generate a single line diagram for a microinverter PV-only system in Solargraf.